Good afternoon. I'm Mary Cook, the ACT coordinator for Metro Nashville Public Schools. I'm so glad you decided to join us this afternoon for our ACT prep program regarding math. We have a couple of very special guests joining us today that will help you through the math portion and getting ready for that math portion. Before I go there, though, I'm going to have Teresa from Conexión Americas explain how to start your closed captioning. If you need this in a language other than English, she's going to explain in Spanish how to start the closed captioning. So, Teresa, go right ahead.
Thank you. Buenas tardes. Me llamo Teresa. Estoy trabajando de parte de Conexión Américas y para hoy la traducción va a ser por medio de en vivo, tradición en vivo, pero como en subtítulos. Y para que vean esa opción, necesitan ir donde dice, hay 3 puntos donde dice, si lo tienen en inglés, dice more, y si lo tienen en español, dice más. Está arriba, está a la parte donde dice cámara y aplicaciones, ponen more. Y después en las opciones que ven ahí, dice language and speech o idioma y le hacen clic ahí y después ponen turn on live captions o que se prendan los subtítulos y ahí ya cuando hagan eso van a salir los subtítulos y cuando salgan los subtítulos hay unos otros 3 puntos que salen a la derecha de eso y si sale ahí el idioma que ustedes quieran que traduzca va a ser hasta abajo donde diga español. Spanish, va a decir Spanish. Entonces van hasta abajo donde diga Spanish y le hacen clic ahí y ya les empieza a traducir lo que ellos están diciendo en español. Así que una vez más van donde dice more arriba, donde dice más, después buscan abajo donde diga language and speech, o sea, idioma, y le hacen clic a la opción que dice ahí turn on live captions y ya salen los subtítulos, las letras, y después van a la derecha donde salen las letras, hay unos 3 puntitos y le hacen clic donde dice idioma o la capción, ustedes la quieren en español. Van hasta abajo donde dice Spanish. Por favor, si alguien tiene una pregunta, me la puede hacer ahorita y yo les ayudo con eso.
Okay, so if you have turned those on, whether you speak Spanish or you want to see this in Spanish, even though you speak English, you should be able to see this scrolling across the bottom of your screen. I am actually going to turn the program over to a guest from our Gear Up Nashville program and as well as a guest from Lipscomb University. I will be hanging out in the background answering any questions that you put in the chat. If you have questions, you're welcome to come off from mute to ask your question or put it in the chat, either way, whichever way you're most comfortable. And I'm also going to be putting in a couple of links into the chat to a document called Preparing for the ACT Test Guide. And I emailed those links out this morning, but in case you hadn't signed up for this until after I sent that email out, that way you will have access to that guide as well. With that, I'm going to stop talking and turn this over to our 2 guest speakers for today.
Hey everybody, my name is JP Gray and I am with the Gear Up program. I want to welcome each and every one of you here today. I know that you've just spent your entire day in your classrooms, hanging out, learning, and doing everything that your teachers are asking you to do. So for you being here this afternoon is a testament to you. I applaud each and every one of you for taking the time to continue learning and understanding what is going to be expected of you through the ACT and preparing for that next step. I'll let my colleague, Dr. Baines, introduce himself quickly.
Hi, everybody. My name is Brendan Baines. I'm professor at Lipscomb University. Really happy to be here with you this afternoon to look at some ACT math and to get some ideas about what to expect.
All right, thank you, Dr. Baines. I'm going to share my screen with everybody. Sorry about that. All right, again, welcome to today's presentation. Can everybody see that? Do I get a thumbs up from Dr. Baines? Can you see that? Awesome. All right, again, thank you guys for being here today. We understand that the ACT is something that is very stressful and something that causes a lot of anxiety. So we want to be here to help you understand that process as you get ready to take the exam coming up in March at your school. Just a couple of things so you know when you take it in March, it will be online. So you'll just have to be accustomed to understanding that you're going to be doing it on your computer at a school, and yeah, just be prepared for that, just so you guys know it's not going to be pencil and paper. And please, Mary or Teresa, feel free to interrupt if there are any questions in the chat that need to be addressed. So getting to know the math section in the ACT. We do know that there are 60 questions and you have 60 minutes to complete that. So 1 minute per question, easy math, right? 1 minute per question, plugging through it. And we'll go through some strategies here shortly on how to attack that process. But our goal is for each and every one of you to get a 21 or higher. And so with these test tips, we hope that that'll help you get there. Why a 21? 21 is traditionally the national average across the entire country. It says that you're ready to go to college, you're ready to do the work. Scholarship dollars come into play. So in Tennessee, we have the Hope Scholarship, where you either have a 3.0 or a 21 on your ACT. And in order to score that, you only need to get 34 of the questions correctly. So again, reverting back to the timing and the number of questions, we have 60 questions to complete in 60 minutes. We only have to get 34 of those questions correct to get that 21 benchmark. Getting to know the content. So there are 3 areas that are tested and scored. Preparing for high school math. We know that 57 to 60% of the questions touch on number and quantity, algebra, functions, geometry, stats, and probability. Now, you might think algebra, I don't take algebra. You're getting algebra through your integrative 1 classes, integrative 2, integrative 3. You're getting all of these skills that you need to be successful to take this test. So they're just lumped into that integrative math class. They're not called out by algebra or geometry. So just know you're getting all those skills right now. Integrating essential skills. So we know the 40 to 43% of those questions are rates and percentages, proportions, area, surface area, and surface area, and volume, and average and median. Okay. The last one is modeling. And these are all kind of just categorized into the previous 2 that I mentioned. And those are producing, interpreting, understanding, and evaluating models. And we'll discuss those here in a minute with Dr. Baines. He'll work through some problems with you to identify which of those meet each one of these categories. So getting to know the content some more. Out of the 4 subjects tested on the ACT, math is the only one that starts out with the most basic questions and gets harder as you progress in questions. So question 1, 2, and 3 are going to be a lot easier than questions 55, 56, and 57. All right. So just again, going back to that, we know we just have to get those first 34 right to hit that 21. So don't panic as you get to 38, 39, 50, that they're getting harder. If you felt comfortable with those first 34, you're good to go. You're sailing and you're doing really, really well. Roughly questions 31 through 60 are more complex problems. They use multiple math skills to solve problems and includes higher mathematics. So trigonometry, pre-calculus, some of those things that you might have touched on this year, but some of those things you might not touch on until your 4th year of math. So again, don't panic if you don't know the material. Test taking tips. We're focusing today on how to approach the test, right? If you have content related questions, please interrupt us at any time, and we will help answer those questions that you have. So again, I said that the exam is going to be taken online, right? So formulas are not provided to you. But we got a question. Are we good there, Teresa?
Yes, just putting in Spanish that they can ask the questions in the chat.
Okay, perfect. Thank you. Formulas are not provided to you. So it would be a good thing to start memorizing some of these formulas, knowing when to use them. So formulas like triangle facts and formulas, circle formulas, Pythagorean theorem, slope of a line. You should be able to look at a problem and know exactly which one you're supposed to use. So just getting comfortable and not in that moment trying to figure out, okay, which one do I use? You can use an ACT approved calculator. Now there will be one provided for you on the platform, the ACT testing platform that you will do online. But if you're more comfortable using one at your desk, you are more than welcome to use it. Just check with your teacher, the principal, whoever it is, to make sure that that's an approved calculator to use on the test. You don't want to use one that will disqualify your test. So just double check with an adult in the building and they'll be able to provide you with that answer. But become familiar with that calculator, right? You don't want to use that calculator for the first time on test day. And then be sure to know when to use it. You're not going to have to use it on a lot of the earlier problems, possibly. So if you can plug through the problems on your scratch piece of paper, you will have scratch paper available for you to work through the exam. You will have to turn those in at the end of the exam, but you know, if you don't have to use it, that's just, remember, we're reverting back to the 1 question, 1 minute, right? To get through this exam, to get through all 60 questions. So you want to make sure that if there are questions that you can answer faster without using your calculator, that you can knock those out and then move forward and use that extra time that you have gained to plug through some of those harder problems by using your calculator. Pay close attention to negative numbers and fractions. Okay, those seem to, you know, mess students up. They're moving too quickly. They're anxious, and just by simply moving a negative number or turning it into a positive can completely give you a different answer. So just be sure to pay close attention. And answer choices are arranged smallest to largest or largest to smallest. So we'll talk about that here in a second and what that means. Next tip I was just kind of touching on is now, later, never. Okay. So if there are problems that you can plug through quickly because you know what formula to use, or you know how to use your calculator in that moment, knock those out. Get those done. Even if you have to skim through all 60 questions, knock out the ones that you know how to knock out. Later are problems that look solvable, but are time consuming. So do them later. You know it's going to add more steps, or you're going to have to incorporate the calculator to solve that problem. So just pushing those back till later. I'll come back to them. Remember, we're trying to get to those 34 questions that we feel comfortable answering, and then any question above that that we get correctly is a bonus. And then never. if a problem involves math you haven't learned yet, so going back to pre-calc, right? Some of us are sophomores in this room. Some of us are juniors. We haven't touched on some of this trig, high-level trig, or pre-calc or calculus. So if you, if you haven't seen a problem like that before, just use the bubble method, okay? And bubble in whatever letter you've chosen for that moment. And then eliminate clearly wrong answers, right? If you're familiar with the math and you know that a negative plus a positive is going to give you a negative, right? You would work in that area, and you would eliminate some of those questions that provide you the wrong answer. Word problems. Know the question. Closely read the problem. Identify what the actual question is. Again, you're going to be anxious. You're going to be nervous that day. So just take a deep breath, read through the question, see what it is asking of you, take notes as you read through it, so that you know that you have the correct information in front of you. You don't want to have to sit there and read it 2 or 3 or 4 times to understand what it is asking of you. Bite-sized pieces. Process each statement one at a time and note important details. So chunk it up, right? Break it down on what is being asked of you so you know exactly how to approach the problem. And let the answer help. Look for clues, use process of elimination and estimating. All right, at this point in time, I am going to turn it over to Dr. Baines, and he's going to go through some questions with you.
All right, thanks, JP. And is it okay if I pull this up in my OneNote for transcribing? Or
Yes.
do we need to? Will that mess anything up with the with the recording or any of that?
No, it
Nope.
shouldn't.
No, it shouldn't. Go right ahead. JP needs to stop sharing, and then you'll be able to share yours.
Perfect.
Yep,
And I have
I'll
all the
look into that.
PowerPoints in here, so.
And while they're switching screens like that, I just want to let all the students know all the questions that you're going to see, these practice questions, they all come out of that Preparing for the ACT Test Guide. So if you want to go back and revisit them later, you can do that as long as you've clicked on that link and downloaded that guide.
Mary, it's not letting me stop sharing.
Let's see.
I haven't had that problem come up. There we go.
There we go.
There we go. All righty. Everybody can see what I have here on the screen.
Yes, we can.
Yes.
Okay,
Yep.
awesome. Very good. Well, I thought it might be nice for us to look at some examples today of different types of problems from different content, and then we'll also start to scroll through and look at different kinds of problems to highlight different strategies. And if time permits, I'd like to give you we'll maybe go a minute per question, just like the breakdown of the ACT, before we actually begin to solve these. So let's go ahead and take a look at number 10. And I'll set the timer here for 1 minute, and then we'll come back in and we'll work through this one, and we'll just kind of do that for all of the different topics here, or all the different content areas. All right, that's our minute. So let's take a second and think about this problem from number and quantity. Katerina runs 15 miles in 2.5 hours. What's the average number of minutes it takes for her to run 1 mile? And so first I'll think about the kind of the math way to do this one. And so the math way is really just to set up a proportion, 2.5 hours. It takes 15 miles in 2.5 hours. And we want to know the number of minutes it takes to run 1 mile. So, X hours for 1 mile. Now, one thing you'll notice in your answer options is that these are in minutes, right? Because if you're just running 1 mile, it's probably not going to take you an hour to do that. So what I thought when I was working this problem, I thought, you know what, I should convert this problem over to minutes. Okay, and so when I did that, 2.5 hours, I converted over to 150 minutes. And again, that's still 15 miles. And that's equal to X minutes for 1 mile. Well, 150 divided by 15 is 10. So it takes X is 10 minutes per mile. And so our answer option here should be option G. Okay, so that's kind of the math way. But when we think, maybe we approach this problem and we are unsure about how to approach it. With this one, I think a good strategy, and I think the strategy will come back around to us, but it might be nice to just note it now, is that these answer options could be pretty helpful here. Could actually save me some time if answer option F is if it's the correct answer, then I should be able to do 15 miles at this pace, and it should take me 2.5 hours, right? So I can just use the answer option. 6 minutes times 15 is 90 minutes, and that's not enough. That's not enough time. So I need to go with another option, and we can just keep doing that. So using the answer options could really be helpful there. All righty, before we move to the next one, any questions about the first problem? All right, let's look at the next one. This one comes from algebra. And here we're given an expression and we're asked what it's equivalent to. Let's do the same thing. I'll give you a minute to just check yourself to see if you have this one down, and then we'll talk about sort of working through this one. Alrighty, that's our minute there. So taking a look at this expression. So this is a multiplication of two binomials. You may have learned the acronym FOIL for doing this kind of multiplication. So if that's the case, that acronym FOIL is the F stands for first, the O stands for outer, the I is for inner, and the L is for last. And so the first product we're going to do is 4C times 3C. Okay, and 4C times 3C is 12C squared. The outside product is 4C times D, so we're going to get 4CD. The inside product is this negative 3D times 3C, so that's going to be minus 9 CD. And then the last product is negative 3D times D, going to give us a negative 3D squared. All right, and we do have some like terms here, but before we combine those, I'll just note one of the potential sort of errors that we could make here is to not include this minus sign that's with the 3D here when we multiply. And if we treated that like it was positive 3D, then it's going to mess all of our signs up. Okay, so we want to pay special attention to that. It's a minus. You could even change this over to addition and make that a negative 3D in the expression if you wanted to kind of protect yourself from making a sign error. All right, combining like terms, 12C squared is still 12C squared. 4CD minus 9CD, we should have minus 5CD. And then minus 3D squared. All right, and the answer option that matches up to that one appears to be answer option C. Answer option C there.
So I'm going to jump in on this
Oh.
because as Dr. Baines said, if you notice that minus 3D times the positive D gives you that negative 3D squared. If you notice that, you could have eliminated 2 answer choices right away and taken them off your plate. Answer option B has a plus 3D squared, and so does D. So soon as you see that minus 3D squared, look at your answers and lop off those 2, and then you're down to just 3 choices. And so that can really help you hone in on what the correct answer is. And I'm sorry if you were going to say that, Dr. Baines. I just wanted to jump in while you were there.
No, yeah, thank you so much. Yeah, no, that's perfect. Great. Any other questions about that one before we move on to our next one? All right, let's look at one from functions. Here we have the number of fish F in Skipper's Pond at the beginning of each year can be modeled by the equation f of x equals 3 times 2 to the x, where x represents the number of years after the beginning of the year 2000. For example, x equals 0 represents the beginning of the year 2000. X equals 1 represents the beginning of the year 2001, and so forth. According to the model, how many fish were in Skipper's Pond at the beginning of the year 2006? Okay, again, take a second and try that one out on your own, and I'll set the timer. All right, that's right at our minute. So we'll go ahead and talk about this one. So this kind of problem fits into sort of, we're modeling with mathematics in this problem. We have a mathematical model. We're trying to use it, and one of the biggest sort of errors I see my own students make. We would do a problem like this in one of our college algebra classes. Is there's kind of this mix up between the years that we're keeping track of, the year 2000, the year 2001, the year 2006, and the value that our variable x is taking on. So I think, JP was talking about earlier, reading your problem and making sure you know the information in the problem. I think this is one of the big things to pay attention to on a problem like this is, okay, we have this function. It's kind of set up for us as long as we know what to plug into it. And so the big hurdle is knowing, is it the 2000, the 2001? Is that what's getting plugged in? Or is it x equals 0, x equals 1, and so on? So, and we know it's from, give this a reread, it's going to be x equals 1 gets plugged in to find 2001, and x equals 6 should get plugged in to find the number of fish in the pond in 2006. So we're going to find f of 6, and that's going to be 3 times 2 to the 6th. Now, of course, you're going to have a calculator handy. I have pre-worked out what 2 to the 6th is, so and you probably have already done it while you were working. I got 64 for 2 to the 6th, and 3 times 64, I got 192. All right, so that corresponds to answer option B. And if we're thinking about strategies on this one, I think one place to think about is what would be too small, and what would be, if any of the answer options, and then what would be maybe too big. Like, could we just throw some out that don't make sense? And I think maybe we could safely throw out answer option E for this model. We're only 6 years in, and this is our equation that shows the growth. I just think it's so far away from all the other answer options that maybe it gets thrown out, right? And so now you've at least, even if you're stumped, you've reduced your number of options to choose from. All right. Any questions, comments on that one before we keep rolling through? All right, let's keep on it going. We have one from geometry here. So in this problem, we have we're in the standard XY coordinate plane. The point 2, 1 is the midpoint of the line segment CD. Point C has coordinates at 6, 8. And we want to know, what are the coordinates of point D? Okay, same deal. Let's take a minute and see if we can find this. Alrighty, that's been about a minute. let's think about this this geometry problem. I think a strategy to pull out from this problem, which it comes up later, but I think drawing a picture is really helpful for this one. We're talking about the XY plane. So let's put it in the XY plane and get a look at the problem. All right, so we are told that the point 2, 1 is the midpoint. Now I'm going to try to make this look decent here. There's 2, 1. It doesn't have to be perfect though. We just want to get an idea of what we're looking at. We know point C is located at 6, 8. Just a little reminder, when we write coordinates, the first coordinate is our X location and our second coordinate is our Y. So I'm going to go over to 6 on the X-axis and up to 8 on the Y-axis to make my point. Okay, and so there's point C. And so this picture can actually help us pretty much solve this problem without doing any calculation. I'll also show us a sort of what's the math way of doing it, like the actual calculation way. But if we're looking for D, right, we're looking for D, and it's on this line segment CD, and we know that this point is the midpoint, then it has to be that our line segment moves this direction, right? It's got to go this way. Okay. If it went this way, our midpoint, we wouldn't pass through it. So it's got to go that direction. Okay, now take a look at our answer options here. Of those answer options, 10, 10 for, well, let's start at the bottom. 10, 15 is up here. 10, 10, also this way. 4, 9 halves. Well, that's somewhere, that's somewhere in here. So that can't be it. The only options that really could make sense with my drawing are F and G, because they actually go back this direction where our negative X values are located. All right, so then if we're just going to use our picture, if we're just going to use the strategy of just using our picture and eliminating answer options, then I actually think we probably could make a pretty good guess that it's going to be G, because we've kind of went from our midpoint, we've went up a decent amount of Y values. In fact, we went from 1 to 8, so we went up 7. So we should expect to go down 7, and that's going to put us down here at -6. All right, so that's just using the picture, no calculations. Let's try it out with a calculation. This problem is really about the midpoint, and there is a formula for that. So this might be one of the formulas to make sure you have memorized before you take the ACT. The midpoint is the X coordinate is the sum of the 2 X values divided by 2. And the Y coordinate is the sum of the 2 Y values divided by 2. Well, we already know in this problem that the midpoint is 2, 1. So we know that this X1 plus X2 divided by 2 should be equal to 2. We also know the Y coordinate is 1. So this Y1 plus Y2 over 2 should be equal to 1. We also know the coordinates of point C. Point C has an X value of 6. So this is 6 plus some unknown X divided by 2 equals 2. And the y coordinate is 8. So 8 plus some unknown y coordinate divided by 2 equals 1. All right, and we can solve this out by multiplying by 2 on both sides for the x's, and we will get 2 over 2 is 1. 6 plus our unknown x value is 4. Subtract 6 on both sides. And so our unknown x is 4 minus 6, which is -2. Do the same thing for our y's. Multiply by 2 on both sides. Eight plus our unknown y value is 2. Subtract 8 on both sides. Our unknown y is 2 minus 8, or -6. So that corresponds to option G. Alrighty. Anybody have any questions at this point? Any questions about using the picture strategy or using that midpoint formula?
It looks like we have somebody typing a question into the chat, so we'll just hang out here for a moment.
Awesome.
And remember, you're welcome to come off from chat too if it's easier to just say your question. I do like, Dr. Baines, that you showed both ways because the math, it's important to know the math, but sometimes the math can bog you down on time. And so that picture option, I'm going to tell you, I've taken multiple ACTs just to make sure that I am still in tune with what you guys have to do. Yeah, so Lottie's saying the same thing. The picture method gets you to the same place a whole lot faster. So just so that we can get this on the recording, what Lottie said is not yet. The picture strategy is helpful though. So yes, absolutely rely on your pictures if that's an option for that particular problem.
Yep, thanks so much.
We have about 18 minutes left.
Okay, awesome. Thanks so much. So we might speed up for the rest of our problems here. Next one comes from statistics and probability, and I think maybe instead of taking the minute to do them, we'll speed up and just do them together. So a bag contains 8 red marbles and 9 yellow marbles and 7 green marbles. How many additional red marbles must be added to the 24 marbles already in the bag so that the probability of randomly drawing a red marble is 3/5? All right, so there is sort of a nice math way of doing this problem, but I'll emphasize that as long as we understand what this problem is asking, we could use the answer options here. So in terms of strategy, let's just kind of go strategy first. We're focusing in on the red marbles here, and we want to add some number of red marbles to get the total number or total proportion of red marbles to be 3/5. So we could just work with our answer options. Answer option A says, let's add 11. Well, there are 8 currently. If we add 11, that's 19. And currently there are 24 marbles in the bag. If we add 11 red marbles, they're now going to be, sorry, that's a 19, but my scratch pad made it kind of messy. 24 plus 11, that's going to be a 35. Okay, and so we can type that into our calculator and say, is that 3/5? And what we'll find is no, it's not. So we'll check that one. Okay, not 3/5. And so we could keep going like that. Check 16. So there are 8 red marbles. Add 16. There are currently 24 marbles, but if we add 16, we're going to get 24 red marbles out of a total of 40 red marbles. Put that in your calculator or however you like to check your fraction to see if that's 3/5. And that's 3/5. Yeah. That's the same as 3/5. And so using our strategies, we can know answer option B is our way to go on number 11. All right, any questions on that one? All right, we'll keep going through. I'm going to bypass setting up an equation for that one because that strategy was so helpful, and we're starting to run out of time. All righty, so you do want to focus on reading each problem carefully. We kind of highlighted that with some of our problems already. You want to make sure you know what information you're trying to find, what information you need, and then kind of choose your plan of attack. Okay, so the fish one was a very good illustration of that. We already solved that one, and it was one of the ones where we highlighted making sure we understood what the variable's value was supposed to be for a given year. And again, students sometimes confuse plugging in the year versus that value. Alrighty, looking at one of our integrating essential skills problems. I figured this category when you see that listed when we were going through the PowerPoint earlier, that seems kind of abstract. What are we really being asked to do when we're doing this integrating essential skills? So this is a good example of it here. At his job, the first 40 hours of each week that Thomas works is regular time, and any additional time that he works is considered overtime. Thomas gets paid $15 per hour during regular time. During overtime, Thomas gets paid 1.5 times as much as he gets paid during regular time. Thomas works a total of 46 hours in 1 week and gets $117 in deductions taken out of his pay for this week. After the deductions are taken out, how much of Thomas's pay for the week remains? Alrighty, so for this one, certainly, if you've had a part-time job, you might be familiar with doing this. I can remember my first job, kind of calculating how much overtime pay I should get, and I would sort of do this 1.5 times thing. So it was really good to help me learn how to do a problem like this, having a job. But we know 40 of his hours are going to be paid at $15 per hour. And so we might do 40 hours at $15 per hour. This is going to give us the total he would make from his regular pay before any deductions. And 40 times 15, however you choose to get that value, that's $600. But Thomas also worked 6 hours of overtime. So 6 hours at 1.5 times. Now, you can kind of choose how you want to think about his overtime pay. You could go ahead and calculate what Thomas makes per hour and multiply by that here when he's working overtime, or you could put it in as an expression here, 1.5 times his regular pay of $15 per hour. Either way is going to give you the same thing. It's just all about how you want to choose to think about it. This may look confusing to put an expression in like that. So maybe if that's the case, go back and think about just what does he make per hour when he's working overtime. That calculation comes out to be $135. And so we know for this 46-hour period, Thomas makes $600 plus $135 before any deductions. So that's $735. Now, one thing to notice is that Our answer options are very clever. If we put $735 right now, we would get the wrong answer because we're told that they're going to deduct $117 from this paycheck. Okay, so we have the correct amount of money that Thomas made before deductions. They're asking for after deductions. All right, so to finish this up, we need to do $735 minus $117. And I did that beforehand. I got $618 total. That's answer option D.
One of the things I want to say is when students see these problems that have a lot of words, they tend to freak out. So as Dr. Baines is showing you, you don't need to freak out. You just need to look for those key elements that tell you what you need to do. So don't go, oh, words, I don't know. Go through, be very deliberate. This is one of those later problems. Remember when JP was talking about do now, do later, don't do it all. This can be one of your laters where you just, maybe you just mark that you want to come back to it. But no, this is solvable. You all have the math skills to do this already. None of the math was complex. What was complex was pulling the information out of the problem.
Absolutely. Yeah, thank you. And one thing I find helpful on problems like that is to also sometimes think about just, what examples might look like. So it just helps me understand the problem. So I think, how much money would he make if he worked, 10 hours and making sure that I can just play with examples of his income before trying to solve this one if I'm having trouble understanding the context. That's sometimes a helpful strategy for me. I also tried to think about other strategies for this one, but these answer options are pretty good. I actually found that some of the strategies I tried, if I didn't understand the problem fully, that I still could be at risk of selecting an incorrect answer. So there are other sort of nice strategies, but you still have to make sure you understand the problem on one of these. All right, drawing it out. One of the most helpful strategies in terms of just understanding a problem, drawing a picture, drawing a graph, drawing a sketch, really, really helps. So here's another one from geometry. And Lotto, he begins at his back door and walks 8 yards east, 6 yards north, then 12 yards east and 5 more yards north, and he makes it to the barn door. About how many yards less would he walk if he could walk directly from the back door to the barn door? All righty. So depending on, you might draw a different picture than I do, but I guess I kind of want my picture on the XY plane, but you wouldn't have to do that. You could just draw it however you like. But we're told he goes 8 yards to the east. So if this is, I'm going to put this is his starting point. That's his back door right there. He's going to go 8 yards to the east and then 6 yards north. So he first walks over this way, up this way, and then he walks 12 yards east, 12 more yards east. So 12 more yards east, that's a total of 12. That's going to put him on my x-axis, that's going to put him at 20. He was at 8, he walked 12 more. That might be helpful to note. And then he's going to go 5 more yards north. So going up 5 more yards. And again, if I'm keeping track of that total distance up here, then he would be up here at 11 yards on the y-axis. All righty. So the question is, how much less would he have walked if he could walk directly from the back door to the barn door? So that would be if he could just walk in a line from the back door to the finish. All right. So we need two things in this problem. We need to know how far Lotto walked in his path. So Lotto walked there's an L trying to squeeze in right there. Lotto walked 8 plus 6 plus 12 plus 5 yards. 8 plus 6, that's 8 east, 6 north, plus 12 more east, plus 5 more north, for a total of 31 yards. All right, so that's 1. 2, we need to know how far he would have walked if he could walk along this linear path. And that makes this problem a Pythagorean theorem problem, one of our big theorems. Definitely one of the theorems to know before taking the ACT. It is for right triangles only, and it says the square of the sum of the squares of the two legs is equal to the square of the hypotenuse. Okay, and so on this path, this line segment here that's 20 yards long would be a leg, and this line segment here that is 11 yards long would be another leg. So if he could walk along the straight line, he would have 20 squared plus 11 squared. That would be his distance squared. And when I did that earlier today, 20 squared plus 11 squared, I got 521. So C squared is 521. And to solve for C, I ended up taking the square root of both sides. I'll do that here. When I did that, C was approximately, I didn't write down an approximate answer, is 521, square root of 521. All right, I did put that in my calculator though, and it was, I think it was around 22 or so yards. All right, so how much could have Lotto saved? Well, we need to do the 31 yards he walked minus the square root of 521, which is what he would have walked along the path. Put that in I put it in my calculator, so I got approximately 8.17 was what I chose to round to. I didn't look at my answer options. And when you look at the answer options, they're rounded to the nearest whole number. So that's 8 yards. He could have saved 8 yards. Any questions on this Pythagorean theorem one?
I put in the chat, every single ACT test will have at least one Pythagorean theorem problem, and all of them that I've seen have been buried within a problem-solving situation like this one. None of them say, okay, here are the coordinates, figure it out. They all put it within this word problem or the situational context. So once you recognize, oh, this is just Pythagorean theorem, you should be able to snap that out pretty quickly. That shows up in early algebra geometry, So most of you, those of you who are juniors, should be well beyond that and be very familiar with the Pythagorean theorem already. We are currently at 4:30, so that is time. JP, what is left that you wanted to share with them on tips and hints? And thank you, Dr. Baines. Appreciate it.
Yeah, no problem. Thank y'all so much.
I'm just going to go through a couple of things really, really quickly. Pull it up. And process of elimination. Just look at, will the answer be positive or negative? You can figure that out really, really quickly based on the signs. Plug and chug, put the number in the answer into the equation and solve. So start with the answer in the middle. Most of the time, the answers are listed from least to greatest. And then practice opportunities. Preparing for the ACT test booklet that Miss Mary just sent out to everybody earlier in the presentation. Mastery Prep platform available to all juniors and seniors. You can access that through your Schoology, parentheses TrueScore. So just look for that TrueScore term. And then free online ACT prep through the ACT Online. You can find that at the address given here. I believe we will be sending out this PowerPoint to everybody. And as I close this out, I just want to say thank you to Dr. Baines, thank you to Mary Cook, thank you to Teresa for all being here, and especially to all the students. We do this all day and every day for you guys. So we want you to be successful. We want you to understand what's being asked of you so you can be successful and you can go on and achieve your goals. Reach out to your teachers, reach out to your administrators. If you're at a Gear Up school, reach out to your Gear Up contact. There's a lot of people that will wrap their arms around you and support you through these next adventures that you have in the coming years. So wishing you the best of luck, and I'll turn it over to Mary to close this out.
Thanks, JP. Thank you, Dr. Baines. Appreciate it. Dr. Baines put his email address in the chat in case you want to reach out to him directly. That's bainesbc@lipscomb.edu. Also, don't forget, we have 2 more webinars coming up. Next week, we'll be talking about ACT reading, the ACT reading section. Yes, I know you guys don't have to come to school. We are still working, so we're going to go ahead and host the webinar for next week as well. And then on the 27th, we'll be doing the science webinar. The recording of this presentation will be posted on MMPS's YouTube channel. There's a playlist available there that has all of the ACT webinars from, we did these last year as well, and we'll be adding this one to it. Additionally, as soon as it is posted on the YouTube channel, I'll be sending everybody out an email that includes a link to that recording, and I'll also include some of the links like the online practice ACT link, Dr. Baines's email address, and so you'll have all the information in one spot. Do be patient. It does take a few days for the video to be prepped to be uploaded onto the YouTube channel. Other than that, unless you have some questions, I'm going to let you go and do your homework and study and prepare for the ACT, and have a great evening. Thank you so much for coming and joining us. Bye-bye.